Okay, hello. I just got back to my office from the 2:30 to 3:30 lecture in Thorndale, and two students came and asked a really good question at the end of class, which was, how are you supposed to use Formula 11? So Formula 11 for converting degrees to radians, a lot of people in class did it wrong. I was like, why did people get it wrong? It turns out the way this formula is written is a little bit confusing. So there is a way to interpret it that seems very natural that is not right. So I'm going to show you the way the author intended you to interpret this formula, and then I'll show you the way I do it, which is the way I did it in class. This is like very slightly different. I'm not going to say exactly what the wrong way to do it is. I don't want you to get it mixed up between the wrong and the right way, so I'm only going to say the right way. Okay, here's the right way. Let's do the example on the next page. So on the example on the next page, we converted 35 degrees to radians, and I did it a certain way. So 35 degrees to radians, the way you're supposed to do this is when you see theta, you're supposed to think of the number 35. So you're supposed to plug in 35 for theta. And so, for example, if you use this formula, you'll get, when theta is 35, if theta equals 35, you get 2 pi divided by 360 times theta. Theta is 35. Rad. That is what it says over here. That's what it says over here. So 35 degrees, that's the left-hand side, because theta is 35, right? So 35 degree symbol is equal to, 35 degrees is equal to 2 pi over 360 times 35 radians. Okay, and if you do that, you get exactly what we got in class, which was, what was it? 0.610. 0.6109. So that is how the author intended you to use the formula. You put in the number. That can be a little bit confusing because, like, okay, if there's theta radians, like, it's easy to get lost. So let me do the version I did in class. I'm going to do it a little bit slower, and hopefully it will help if you're confused. Let's do a new page here. New page. And what I'm about to say really applies for converting between any two units. So let me do it, let's not even think about radians. Let's do it with inches. So there's 2.5 centimeters is equal to 1 inch. 2.5 centimeters is 1 inch. And if 2.5 centimeters is 1 inch, then 2.5 centimeters divided by 1 inch is nothing. I just divided both sides by 1 inch. 2.5 centimeters divided by 1 inch is the number 1. It's nothing, right? It's the same thing on the top and the bottom. You divide them out, you get 1. By the same token, you can divide it out the other way. You can divide it out the other way, and you can say that 1 inch divided by 2.5 centimeters is also 1. Okay, and if you have these two facts memorized, but this is how I do it. You keep track of these two facts, things that are equal to 1. Then if someone gives you something to convert, they say, write 7 inches in centimeters. How would you do it? You'd say, well, 7 inches is the same thing as 7 inches times 1, right? Multiplying by 1 doesn't do anything. But 1 is 2.5 centimeters divided by 1 inch, right? And the point is here, I've lined it up. So there's an inch on the top and an inch on the bottom. And inches divided by inches is nothing. That cancels out. So it's on the top and the bottom. That cancels out. So you end up with 7 times 2.5. 7 times 2.5 centimeters. And look, the centimeters is there. So that's 7 times 2, 14, plus 3.5, 17.5 centimeters. 7 inches is 17.5 centimeters. And you can't screw this one up. You can't screw this one up because if you do it the wrong way, so here is the wrong way. This is like bad. Don't do this. Bad. If you tried to do it the wrong way, you would get 7 inches times 1. And if you put in the wrong way, 1 inch divided by 2.5 centimeters, as long as you're writing down all the steps, you'll notice it does not cancel. So look, you have inches on the top and inches on the top. So if you did it the wrong way and you got to here, you should go, oh wait, something is wrong. It's not working. And then a little red flag goes off in your brain that's like, oh no, terrible, like do it again. And then you go back and do it the right way. So that's the way I like to do it. It has this like error checking built into it. Let's do it with radians and degrees because that's what the course is supposed to be, radians and degrees. So let's do the problem one more time. 35 degrees is how many radians? Well, 35 degrees is the same as 35 degrees times 1, and 1 is the same thing as 2 pi radians divided by 360 degrees. And once again, radians are not a real, like you don't have to write the unit radian. I'm just doing it here to be extra crystal clear. So 2 pi radians is the same as 360 degrees. So 2 pi radians divided by 360 degrees is 1. That's how I replace the 1. And now the degrees are exactly lined up to cancel out. The degrees cancel on the top and bottom, and you get 35 times 2 pi divided by 360, and that was the number 0.61 ... from class. So I hope that clears it up. I think the students who came up to me at the end of class, thank you so much for coming. I think it really, like, this can be super confusing if you kind of read it in the natural way. It turns out it's wrong. So if you kind of like think that the 35 degrees is supposed to be 35, that's where you put the 35. Like, you can get it wrong. Thank you very much, and hopefully this video helps somebody. All right, I'll stop there when I can find the button to stop. Where is it?